Okay, so moving on, let's actually just see if we can actually get the no such element exception to actually basically be invoked as an exception in our error, as an exception in our program. So first, if we run the program, we enter something invalid. We obviously get the input mismatch exception, but that's not the error. This is the one we actually want is no such element exception. So how do we do that? Well, let's just try running it again. And instead of typing in something that we know isn't a number, there's another command you can type. You can press Control-D on a PC or a Linux machine while you're in the run window. Or on a Mac, I've got to press Command-D. And when I do that, that's going to actually send the ASCII EOT, end of transmission character, to the program. And that abruptly terminates any input. So if we just do that to confirm it works, you can see the Command-D has been shown, even though I pressed... actually, I'll just run that again, so it's clear what's happening. And if you just look at the green little output, that when I actually click on that, I'm pressing Command-D, but again, you do Control-D on a Windows or a Linux machine. You notice send EOF via Command-D, and it's Control+D for Windows. Linux was actually sent through. But the point is, we've now got the no such element exception thrown because of that. So by subclassing the no such element exception, the creators of the scanner class allowed programs finer control over how they respond to the exception. So we've got multiple exceptions actually happening here. So if we go back into the scanner class and we go and click on the no such element exception, and notice how it extends the runtime exception. We click on super. We're now in the runtime exception. And notice how the super is being called. I click on super again, and we should get straight to exception, which is sort of the base class, if you will. It actually extends throwable now, not another exception. So we can go through again to exception by clicking on the super. And we get to throwable. And you can see now that the throwable has actually got a method in there to fill in stack trace. So as a result, as long as the subclass exceptions constructor calls super, the stack trace is automatically going to be available in output, like you can see on the screen there. Now, there are other constructors for most of these exceptions, and you may have caught a glimpse of that as I was quickly clicking through. And these can allow a method to add more information to the exception before throwing it to its calling method. But I'm really getting ahead of myself here, so let's just go back and modify the program to start catching the exceptions and look at the options we have for dealing with them. So I'm going to close this run window down. And we'll close down throwable for now. We don't really need half of these. I'm going to close all these other ones down that are part of Java and just get back to our code. There we go. So we're back in our example.java now. So let's look at our getInt method. So starting at this lowest level of the program, the getInt method can get an exception when there's no more input available or when the input doesn't represent a valid integer. Now we could catch the exception, but if we did, what would we do with it? And generally speaking, there's no point catching an exception unless your code can do something sensible with it as a result. And here, there's really no action that can be taken if there's more input available. So catching the no such element exception is therefore really a waste of time in this method. The only really sensible thing to do with it is to allow it to propagate to the calling method, and that will happen automatically if we don't catch it. Now, a little later, I'm going to discuss the two different types of exceptions, and we'll see that sometimes you may want to deal with the exception in some way, even if you only want to propagate it. Now, as I mentioned, I/O is a good source of potential errors, so it makes really more sense to discuss checked and unchecked exceptions using more realistic examples. But our exceptions here are unchecked, and we can just allow them to propagate automatically if we can't handle them sensibly in a particular method. Now, there is a possible action that we could take if we get an input mismatch exception. We could request another integer from the user. So let's make some changes to the getInt method to do that. So we're going to, instead of just returning s.nextInt, let's have a method to continually ask for input until we've got something valid. So the way to do that's pretty straightforward. We're going to put a while true. So basically that means, we talked about this before, but it's going to continue executing until we explicitly break out of it. Then we're going to put a try in there. And we're going to catch just the exception we want to deal with, which in this case is input mismatch exception. And in the case of an error, we're going to go around again and read past the end of line in the input first. So we need to do an s.next line, which we've talked about in previous videos, to basically read past the end of the line so that we can actually start fresh again. And then we're going to put a message. Please enter a number using only the digits 0 through 9. 029, probably better. Like so. And then in the try block itself, we'll put our return code in there. So obviously that's going to be invoked, the code on line 28, if it's valid. If they have typed a number in, and the code basically from line 30 through line 32 is only going to be invoked and used if there was actually an error. So let's run that first and check that it does work. Okay, and you can see on lines 17 and 18 it's asking for 2 integers, so we're going to enter the first one correctly, second one correctly. X is 123, Y is 124, so that's working out okay. And if we check it again, put something invalid in, ABC. It's continually asking, now we enter something valid, 100. And again, that's working quite nicely. Put 50 in there. The answer is ultimately 2. So bear in mind that I'm explaining about exception handling here, but it is very difficult to be able to guarantee an exception. Now, dividing by 0 and the scanner.next int methods are 2 ways I can be sure of generating an error, which is why I'm actually using them in this example. But this new getInt method is very wrong for several reasons. So please do not use this as an example of how to get input from a user in a real program. Later examples are going to do that much better. And just to confirm, if we run it one more time, we've seen what happens with valid and invalid input. I can do the Command D, which is Control D on PC running Windows or Linux. I can exit, we get the no such element exception, and note how that wasn't trapped with our exception here because we've only caught the input mismatch exception and we've put some code in for that automatically, but the no such element exception wasn't caught and it went back up the chain as we talked about before. And the reason we did that, we decided to be left for the calling method to handle that error rather than actually handle it in the getInt class itself. Now the calling method is divide, and as well as receiving an exception from getInt, it can also get one by attempting division by 0. So once again, there's really nothing sensible that this method could do with either exception. Because if a method can't perform the function that it's supposed to perform, then the only thing it can realistically do is inform its caller about the error. So the first attempt earlier returned 0, but if this was part of, say, an aircraft navigation system and it returned 0 when it really meant the starboard engine is on fire and my sensor is burnt out, you can see that the consequences could be quite serious. But in this case, we are looking at exceptions, so I'm going to press on. So let's really annoy the user at this point by attempting to catch the no such element exception and insisting that they enter a number. So the first attempt to this could be something along these lines. Let's look at the divide method again. So I'm going to add a try. And we'll put the first X call in there like so. And we'll add a catch. No such element exception. E X equals getInt. And leaving the rest as it is on line 23 through 25. Now this is very common when adding a try block to code, because you can see now that X has suddenly become undeclared on line 21 and 24. It happens because a try block is the same as any other Java block as far as scope is concerned. So what we'd really need to do is declare X outside of the try. So we need to come up here and put int X and then get rid of the redeclaration of X and just leave it like so. And by removing that, it's then going to be valid. So if we run this, firstly checking that it works correctly for the valid inputs, then running it again. And this time if I try and exit with my Command D, we've noticed it's still crashed. And that's because although we caught the first exception, our exception handler then attempts to retry the operation that caused the problem by calling getInt again. And this results in a second exception which isn't actually caught. So that's why it's crashed for that second time. So, it is valid for an exception handler to try and recover from an error condition, but it's important to make sure that any code in the exception handler, the catch block in other words, doesn't actually cause exceptions itself. So Control D is close the program's input stream. So even though getInt creates a new scanner, any attempt to read from it will continue to raise no such element exceptions in this case. That's just a feature of the scanner essentially. So the upshot is that we really shouldn't have tried to do that there in the catch block. And of course, we've already decided it was a bad idea for other reasons, but I went ahead and did it anyway, really just to demonstrate the importance of ensuring that exceptions are not raised in your exception handler code itself. A catch block is there to catch one or more exceptions, and as their name implies, exceptions are things you should not normally happen in the general scheme of things, but we should guard against them in case they do. Keep them simple to try and make sure that they don't go on to cause more exceptions is really the rule here. So it is possible to nest a try catch block inside a catch block, and sometimes it can be useful to do so, but the best advice I can give you is to keep your catch blocks as simple as possible. The less code there is in a catch block, the less chance there is of another exception being thrown. So it's now pretty obvious that we can't do anything sensible inside the divide method if we get an exception from getInt. And we've already decided that there's nothing we can do with an attempt to divide by 0 either. So we could let both the no such element and arithmetic exceptions automatically propagate up the call stack and let the main method handle them both. But what we can do is make life easier for main by throwing a single exception in both cases. So this is a good opportunity for you to see how to throw exceptions anyway. So to throw an exception, you create a new exception object and you use the throw statement. Generally, you should try to be as specific as possible when using an appropriate subclass of exception rather than throwing exception itself. Now, as our divide function performs integer division, throwing arithmetic exception seems like a good choice. So we can also use the overloaded constructor that takes a string for the exception so that we can provide a bit more information on what actually happened. Now, this is not really intended for the calling method, but it's useful in log files when a human has to work out what happened. So we should also include the second call to getInt inside the try block so that to do that we're going to have to declare y the same way we've declared x. So let's just go ahead and clean up our divide method. So int x, y, like so. And we're going to put the y in the try block as well. Remove the declaration because it's already now defined on line 18. And we're going to remove the x equals getInt from the catch. Instead, we're going to throw an error. So we're going to do a throw new arithmetic exception. We're going to put no suitable input. That can obviously be whatever you want to be put there. And that's going to be, we'll be able to see that on the screen. So that's the first one, retrieving the data. Then we're also, after outputting the result, the input, we're going to add another try block. So try, we'll put return the division result in the try block, and then we're going to catch arithmetic exception again. And we're going to change this to throw new arithmetic exception. This time it's going to be attempt to divide by 0. Like so. If we actually run this, first if we try and exit, so we'll just try and do my command D. You'll notice how we've now got an exception thrown. Exception in thread main, no suitable input. So that's our first exception now being generated, which is good. So you can see that that's working. And if we close it down again and run it again, and this time we'll put in a valid number, but make sure the second one's 0. And we get our arithmetic exception attempt to divide by 0. So clearly that's now working as well. So when the program's run and either of the two exceptions are triggered, as you saw, the stack trace is then much simpler. Actually, I'm not sure whether you noticed that, so I'll just do it again so you can see it. But notice the stack trace is a lot simpler now. It's really only referring to our code. And that's because the exception originated in the divide method, so Java doesn't need to show any other methods that were being invoked. The code as we've written, though, looks a bit clumsy. And we'll look at fixing that up in the next video.